I don't know if they're cashless these days, but, or maybe Fryeburg Fair's cash only, aren't they? A lot of times the booths are cash only. Okay, so this says you have $50 in your wallet to enjoy at the Fryeburg Fair. You've already paid your admission cost, which is what, like 12 bucks or something. So anyway, now you have $50, you're in the fair, and it says you plan to spend your money on rides, which cost $5 each. It's not a bracelet day. I'm not sure if that's accurate. I just estimated because they take different numbers of tickets, right? So let's just say it's $5 per ride. And for food items, I'm just saying on average it's $8. So maybe you bought an ice cream or an onion, bloomin' onion, or a sausage, whatever. Let's just say that a food item costs $8. I know that they're all different prices, but use these prices to answer the following questions. What's the maximum number of rides you could go on? Could you purchase 8 food items? Why or why not? And part C, could you purchase 2 food items and go on 2 rides? How much would you have left? And give another example of rides and food items you could afford. So I'd like you to take a few minutes on your own and see if you could answer those first few questions, or work with a partner beside you, and then we'll think about graphing inequalities and how it fits into this problem. So this is just using those numbers. You've got 50 bucks. How much of these things could you do? Some of these answers. Maximum number of rides, you should have just taken $50 and divided by 5, right? 50 divided by 5 is 10 rides. If you spent all your money on rides, right, you could go on 10 rides. That's why the bracelet deal is such a good deal, right? I think they usually have a bracelet day the day we have our early release for Columbus Day, like that Thursday. Isn't that usually a bracelet day? So, because the bracelet's what, 25 bucks or something, and you get to ride. Although, aren't the lines really long on bracelet days? So, I don't know. Can you purchase 8 food items? No, why? No, 8 times $8 would be $64. So that's too much money. Can you purchase 2 food items and 2 rides? So 2 food items, that would be $16. 2 rides would be 10. So you would have spent 26. How much would you have remaining in your pocket? Yep, you'd have $24 remaining. Maybe you don't want to spend all $50 at the fair, right? You just have it in case you need extra. All right, give another example of a combination of rides and food that you could afford. So give me an example. Who did one other combo? Yeah, Noah? 3 food and 5 rides, 25 and 24. That's pretty good, right? What's that, 49? Oh, so you spent almost all your money. Okay, that's good. You could just do 1 food item, right? Spend $8 and that's all you spend or something. All right, so what this says, let's write an inequality to represent the number of rides. So what's the biggest number of rides that we could go on? We said 10, right? So doesn't x have to be less than or equal to 10? What about an inequality to represent our number of food items? How many food items if we just bought food? So you can count by 8s, right? 8, 16, 24, 32, 40. I think we can get to 48, right? 6 items. 6 times 8 is 48. So y has to be less than or equal to 6. All right, now this says, let's write an inequality that represents combined food and rides. Well, we just said each food item is what? Wait, is x? X is rides. So each ride is 5. So $5 times x plus $8 times y has to be less than or equal to $50, right? Does that take into account everything I need to know? And I wouldn't expect you to get, question G on your own because we are just, barely introducing inequalities and applications. And this is not going to be the focus of, Friday's test by any means. So this says, let's graph the system of inequalities together. So the first line is what? X equals 10. What type of line is x equals 10? A solid vertical line. Let's not shade anything just yet. So if you need a ruler, you're doing a ruler, vertical line at 10. Don't shade anything yet. Who needs a ruler? I think I picked them up because they were all over the floor. All right, and then you can draw your horizontal line for your Y. Anyone need a ruler? Show me. That's one you can copy. Show me some stuff. Randolph, the coffee. Ruler, ruler. Ruler, ruler. Ruler, ruler. All right. So I've got a vertical line at 10, and I'm going to do a horizontal line at Y has to be less than or equal to 6. So I'm going to draw a horizontal at 6. Okay, how am I going to draw this line? 5x plus 8y is less than or equal to 50. Let me show you a standard form trick. Remember standard form? We barely talked about standard form, but finding an x and y intercept and connecting the dots is a little bit easier than setting this equal to slope-intercept form. If I cover up the 8y, what is my x-intercept? 5x has to equal 50, so x has to equal 10. All right, so I'm going to put a dot here on the x-axis at 10. And then I'm going to cover this up. How many y values, right? 8 times what gives me 50? So I could take 50 on a calculator and divide by 8. Can someone tell me, what is 50 divided by 8? 50 divided by 8. 6.25. I heard a couple of you say it. On the y-axis, let's go to 6.25. Would you agree that that's the x-intercept and that's the y-intercept, and I can connect them and form a line? All right. This is going to be your solution region, because I have to be underneath the horizontal line, I have to be less than this vertical line, and I have to be underneath this $50 slanted line. So these are all the possible combinations. And wasn't there one combination that Noah gave us? He said 3 of the food items and 5 of the rides. I got to label this for myself. This was rides and this was food. He said 5 rides and 3 food, and his point is right there, right? 5, 3. See how that's one of our possibilities? And someone could be over here. They could do one of each, right? They could get one food and 1 ride. So anywhere in this region is called the solution region. I can get any combination of rides and food that's in this solution region. So I just think it's a real world problem. I know it's kind of silly, but anything in this region you can afford, but you can't afford something out here, right? So I can't do 6 rides and buy 9 food items, or I'll overspend. So I just think that's a good way of kind of thinking about an inequality. All right, so I want to do a couple more with you and give you some time to practice inequalities. So we are going to actually do a quiz tomorrow on inequalities. Just really quick, graph these couple inequalities just because it was a bonus on your last quiz. So for some of you, you guys are at, this is page 115, 9, and 10. We haven't done these yet. And think about, let's think about this first inequality on number 9. A little bit tricky because I have to divide by a negative number before I can start graphing it. So if I divide by a negative number, what do I have to do? You remember? Divide by a negative, flip the symbol. So y is greater than negative 2x minus 4. So I've divided by negative 2. This is page 113, the guided practice. Okay. Let's graph that. And I'm going to think about, this is going to be a dotted line because it says strictly greater than. So I'm going to go to -4 on the y-axis. This is the day to finally get consistent on graphing these lines. We've got to master that skill. And then I'm going to go down 2 over 1, right? -2 over 1. Down 2 over 1 would look like this direction, right? Negative direction. And I'm going to make that a dotted line. So dotted like that. Where should I shade that guy? So let's see. Y is, it says greater than -2x minus 4. Where are the y values bigger? Up here, right? On the y-axis, these values are bigger than down underneath. So I'm going to shade above that line. So I'm going above. So I've got this red region for the first part of this answer. So there it is. All right, the second line, y is greater than 1/3 x. I'm going to write +0 so that I can remember my y-intercept is 0. I'm going to start at 0 and go up 1 over 3 in the positive direction. Should, you know, I'm gonna circle this one that I did it in red in case it's hard for you to see which one I did. I think I'm gonna do my other one in like blue. Let's see, 1/3, it's gonna be dotted. It says greater than. So dot that guy in. Y is greater than. So that's gonna also be above. So I'm gonna go this way. I went above this line and I went above this line. And there should be one region where they overlap if there's a solution. Where do they overlap each other? Right here. So this whole area is where I would find all of my solution possibilities that make this true. So I don't know. Some people have been kind of making it like really dark around that region, or you could draw an arrow to that region, or you could label it feasible. You know, you could write the word feasible region or solution region. Somehow on your quiz, make sure to indicate the final answer when it's a system. All right, let's do one more together, and then I'm going to have you do a matching practice before you graph these by hand. There's a cool matching practice, kind of like, you know, take it as a quiz and see how many you get right without having to do a whole lot of work. Number 10, what kind of line is x equals 5? Right, you can think of this x equals 5 if you wanted to. X equals, what special line is that? It's dotted, and is it vertical or horizontal? You're right the first time. Vertical, undefined, x equals 5. Hopefully this is helping you practice your facts about lines so that, you know, if you went back now and took quiz number 1, do you think you could do better on it? So if you got a 60, you know, on quiz 1 and you want to come this week and retake it during flex, I have a retake for that quiz too. If that would help build your confidence going into the test, I'm all for it. This is the first time you've had me as a teacher. You weren't so confident with your Algebra 1 skills. I'm all for taking some retakes on these quizzes this week if it's going to help build your confidence. You know, your test will override it anyway, but only if it's better. If you bomb the test, it's not going to override it. But so x is greater than 5. Where are the x values bigger? Over here, right? The x values are bigger. So this is where I'd want to shade. All these x values are bigger than 5. So that is my first inequality. The second one, how am I going to get y by itself in the second one? Yep, and what am I dividing by? I'm dividing by -4, and that's going to trigger what to happen? I have to flip the sign around, right, if I divide by a negative. So now this is going to be greater than or equal to negative 1x minus 2. And this is helping practice this skill for graphing lines, right? We had to do this on quiz 1. Get y by itself to graph the line. So all those skills you guys have now been practicing for an extra week. All right, this is going to be a solid line this time, right? Because it says greater than or equal to. And I'm going to start at negative 2 on the y-axis, and my slope will be down 1 over 1. So here's negative 2, down 1 over 1. Solid line. All right, y is bigger this time. So all the y values are bigger up here on the y-axis. So I want to shade above the diagonal line. So basically this entire triangle, and then I see that there's an overlap here, right? All this area will be my feasible region because it's purple and red. So what if I ask you a follow-up question on the quiz? Like, is 1, 1 a solution? Let me just put it up here so someone watching this. How can I figure this out? Now that I've got this graph in front of me, is 1, 1 a solution? What would you say? So where is 1, 1? Right here. Why would you say that 1, 1 is not a solution? What would be your reasoning? It what? It's not in that feasible region, right? It satisfies the purple, but not the red. So 1, 1 doesn't work. Can someone give me a solution that falls in the feasible region that I could dot? What'd you say, Jake? 9, 1 is right here. So that would be, if I plugged in 9 and 1 up here, then everything should be made true. So you can always check that you have the right solution. All right, you're going to give yourself a little quiz here. So turn to this. I really like this multiple choice practice. It'll take you a little bit to work through, but each of these systems, like on number 1, one of these is the correct answer. So when you graph, you might have to rearrange the equation. Think about when you graph it, which of these would be correct, A, B, C, or D. So you're going to put your answer on this line right here, right? So these are the two equations. One of these is the correct graph. Write your answer on the line. Maybe by process of elimination, you can get rid of some of the possibilities. Y and 2, that's a special kind of line. So I would graph the easy line first, figure out if you've got anything else that you need to check. So there's a total of 8 of those. So, you know, if you want to work with a partner, that's fine, but think of it as kind of like an 8-question quiz, multiple choice. I think these are good test prep for seeing them on the SAT as well. And I might give you one of these